All right, guys, so welcome back. We're gonna finish this day 4, and really on day 4, the only thing left is to do 2 full AP problems. And I kind of thought I'd get you motivated in my Carol Baskin little outfit here, and let's see how we do. All right. So, first one, Maclaurin. Ooh, we haven't seen that in a while. What do we know? We know we're centered at 0. So the Maclaurin series here, and here I can see I'm centered at 0, is this right here. They give us the first 3 non-zero terms, the general term, and then they say it converges for some absolute value of x less than r, and we are good because we're centered at 0. So they've kind of already simplified that. And r is the radius of convergence. Great. A, use the ratio test to find r. Well, thank you for letting me know which test you want me to do. So let's go ahead and do that. Here we go. A. So I'm going to take the limit as I go to infinity of the next term. So when I plugged that in, it wasn't n minus 1. So when I do plus 1, it's just going to be n. I don't know why I just wrote it like that. Let's keep it in the numerator. Seems to make more sense. It's 1 times the original being flipped. Okay, and now let's go reduce that. So that's going to be left with an x and an n on the top. And then those canceled, so I have negative 1, and plus 1. And I'm going to rewrite it one more time because I don't like that negative 3 to the negative 1. I'm going to go ahead and bring it up to the top. And now I know that I'm taking the absolute value, so I don't need the negative at all. And limit as n goes to infinity, they are the same. So I take the coefficients, which would be the absolute value of 3x over 1, or just the absolute value of 3x for that. So see if you got that okay. And now we know that that's going to converge. And the absolute value of 3x is less than 1. So we're going to pull out the 3. Excuse me. And so now we're in the form, the absolute value of x minus 0 less than my radius of convergence. So did it ask for the radius, or did it ask just ask for the r? So just the radius of convergence. So here I can see that r is 1/3. Okay. All right, so let's look at B. Write the first 4 non-zero terms for f prime. So let's go ahead and do that. So if I'm going to need 4 terms, then I probably want to go out one more here. So if I went, let's see that's 1, 2, 3, so then I'd be on 4. So let's go ahead and do that. So negative 3 to the 3rd would now be negative 3 times 3 times 3, 27, over 4, and then x to the 4. Okay, so let's go ahead and find that f prime. So this would now be 1. Derivative of this guy, bring down my 2, is a minus 3x plus 9x squared. Then bring down the 4 and they cancel. So that's nice, minus 27x to the 3rd. So there's the first 4 non-zero terms. This is going to be like approximated. And then it wants me to write f prime as a rational function. So when I see that I have this rational function, rational expression, I'm thinking the a over 1 minus r. So if I look at this, let's go ahead and write the general term so that that can help me here. So I'm going to take this general term, bring down my n, that kind of cancels. So I have this negative 3x to the n plus dot, dot, dot. Okay? When I look at this general term. So now when I have my general term going on, I see, oh, yeah, I can see my a over 1 minus my r. And you can simplify that, but that's basically going to be, here's your first 4 terms, and then here is your rational function. Okay, part C. Write the first 4 non-zero terms for e to the x. Sweet. You're like, we've got that down. We've got that memorized. As long as you don't forget the factorial part like I did the other day. Okay, so we have, there's the first 4 terms. And now it wants me to write this g of x is e to the x times f of x. And we had f of x up above. So I have like this e to the x times that x minus 3/2 x squared plus from what we saw above. And that e to the x is that part. So now we have these two series that are kind of being multiplied. So this is where I like to go and get this set up more in a box. And how many do I have to get to write the 3rd degree? All right. So I know I don't need to go past the 3rd degree. And 3 factorial is 6. I'm going to go ahead and simplify for that e to the x. And then I'm going to write my f of x part. Okay. And as I'm taking and multiplying, I know that I don't need to go any further than things with a 3rd degree. So that's going to be too big. Now those are too big. Now those are too big. So now I'm going to put together, there were no zeros degrees, so I'm going to start with the 1st degree. And then I can go to the 2nd degree. So on that one, I'm putting together a negative 3/2 plus a 1 is 2 over 2, which would be negative 1/2. And then the last ones that we want to put together are the 3rd degrees. So I'm looking at my coefficients, and I have a 1/2, a negative 3/2, and then a 3 is the same as 6/2. So kind of put those together, that'd be what? 7 minus 3 is 4/2. So 2. And there we go. Okay, let's do the next one together. On this one, they told you E. You're like, okay, thanks, but I knew that. Okay. All right, and then they are giving you, and you're like, oh man, I wish I could have just found E instead. But they're giving you this bumba jumba for f of x. And then they give you a point as well. Okay, here I can see that it is being centered at 1. I can see that from here and here, as they were making this function. Okay, so let's go see what they want us to do. A, write the first 4 non-zero terms and the general term for this. Well, that's not too bad. That says, hey, start with E, which they already gave us. And then everywhere I see an X, I'm going to plug in this right here. So let's go do that. So squared and squared would be now to the 4th. And then squared and to the 3rd would be to the 6th. And then squared and 2n, and the n would be 2n. There we go. So there's the first 4 non-zero terms and the general term. Now it wants me to do f. Okay, so here in f, we just found this piece. So that was kind of like the first step. Then it says subtract 1. Okay, so we're going to take what we had and it said first go subtract 1. So if I subtract 1, I'm basically getting rid of that first term. So subtracting 1 would give me just that x minus 1 squared minus 1 so far. Just takes away that first term of 1. So then the next part that they tell me, so that was the second step, is to divide everything through by x minus 1 quantity squared. So I'm going to take every single term left and divide by x minus 1 squared. And before we said we may have to rewrite that as a multiplication if it's not coming up with what we kind of want. But in this case, that's all right because they're going to be canceling as we go. And so it's nothing too crazy. So we're going to take all of those terms and do that x minus 1 squared. Sure, I'd also write it over here so I don't have something that's not equivalent. So now this is approximately, that first term just goes to a 1. And now I have x minus 1, 4 minus 2 is 2, still over the 2 factorial. And then 6 minus 2 would be 4 left, still over the 3 factorial. How many terms did it want me to do? It said 4, so I need to do one more. So I'm just going to kind of use the pattern. This was 0, 2, 4, so I know my next one would be 6. And this was 0 factorial, 2 factorial, 3 factorial. This one would be 4 factorial. Plus dot 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 plus, and we can simplify that. X minus 1 to the 2n minus 2 over n factorial plus dot dot dot. Okay. So we really just had to make sure we understood the steps. And I will tell you, I have seen kiddos who try to subtract 1 from every single term. And that's not true. This just says take what you had and subtract 1 time. It's not like you're multiplying or dividing by every single term. And that's usually the biggest mistake is that one right there. Okay, here we go. What's the next one? C. Use the ratio test, letting you know what they want, to find the interval of convergence for what we just had in B. So back here in B, we found that we were looking at this F, and we said it's this guy. So it wants us to use the ratio test on him, and let's go for it. So first we're going to do the absolute value of the n plus 1. So if I do 2 times the n plus 1 minus the 2, I have 2n plus 2 minus 2, which gets me to 2n. Okay. Okay, I'm going to reduce this a little bit. So this would be x minus 1 when I reduce to the negative 2 when those cancel, so I'm going to go ahead and bring it up above and make it a positive 2. And then those, I'm left with just the n plus 1 on the bottom. So as I go to infinity, oh my gosh, it's our favorite. We get 0. So this interval of convergence is from negative infinity to infinity. It converges everywhere. Yeah. Oh. All right. So now we're on part D. And it wants me to use the Taylor series for F. So F was right here. So I like to try to label things so I can easily find it. So there's my Taylor series for F. And to determine whether the graph of F has any points of inflection. So F, and we had it written out right here as well. Okay. F up here was this, I'm going to go ahead and write it so we can see. F was this 1 plus the x minus 1 squared over 2 factorial plus x minus 1 to the 4th plus x minus 1. It's just easier for me to see it. Oops, n factorial. So if I want to know any points of inflection, then I need to know if that second derivative can be 0. So let's go ahead and find the first derivative. And you can either do it term by term, or you could do it for that general f that we have going on. That's completely up to you. I'm going to go ahead and just kind of do it term by term. So that goes to 0. This 2 comes down and cancels, and I'm left with x minus 1 to the first. Plus, bring my 4 down. I have x minus 1 to the third now over 3 factorial, because the 4 cancels with that 1 4. Plus, dot, dot, dot. I'm going to bring this guy down, 2n minus 2 times x minus 1 to the 2n minus 3 over the n factorial. Plus, dot, dot, dot. And when I take my second derivative, I'm going to get another term here just to kind of help me out. But so this part becomes a 1 plus this 3 comes down and cancels. So I have x minus 1 squared over the 2 factorial. And that one was harder to see. So I probably wanted to go out maybe another derivative here to kind of see what was going on. Oh, I'm so glad I did that too. This one wasn't a 4 factorial to start with. That was a 3 factorial. So this one wouldn't be a 3 factorial. This would still be 4 and 3 factorial there. All right. So up here, if I took this derivative, that would be 6 x minus 1 to the 5th over 4 factorial. And so I'm going to derive that one. So that would be 30 x minus 1 to the 4th. And we were on, oh, I hate scrolling up and down. 4 factorial. Sorry. I went too far. Oh, so hard to see. This one was still reduced, so that was a 4 factorial. Okay, so let's see if I can get this reduced at all. Guys, I'm gonna try to have more room. Like, I'm sorry, I know I don't want to waste your time. But this is really hard to go up and down. So I'm gonna erase all of this and then use what I had up there. I can't keep scrolling. It keeps messing me up. Eve, come on, move. Well, now I'm frozen on my screen. I can't get it to work. Ah, okay. So I'm gonna, like I said, I want to erase all of this for my part B, so I don't have to, I can actually see with what I was doing, because I think I made some mistakes, so just backtrack with me. Let's go see. Maybe this will be good for you just to hear it one more time anyway, right? Silver lining. Okay, so this was my F, and I felt good with that. Yes, I did. Might want to have that. Okay, so I'm going to write it here so I can clearly see. So this was 2 factorial. This was 3 factorial. Let's see what's going on. First derivative, 0. This one, I'm going to bring down. Those cancel. This one, I'm going to bring down my 4. Still have that. This one, I'm going to bring down my 6. Still have that. When I can bring down this guy, subtract 1, and I still have that. And let's go to the second derivative now. 1, this would be 4 times 3, x minus 1 squared over 3 factorial, 30, x minus 1 to the 4th over 4 factorial, 2x minus 2, 2n, not x, n minus 3, x minus 1 to that 2n minus 4 now, over n factorial plus dot dot dot. Okay, so there's my second derivative. We can clean that up a little bit if we want. So this would be 12 divided by 4 times 3. So it's going to give me 2. So 4 times 3 times 2, 3, 10, 5. So 5/4 even. Okay, which we didn't have to, but so we're kind of looking at this and it says, hey, as I am doing this, could I ever get this to be 0? So is there anything I could plug in to f double prime of x to get 0? Can I ever have a point of inflection? And in fact, is there anything I could plug into that where I can see it's less than 0? Or anything I can plug into that where I could see it's greater than 0? So think of absolutely any number now as you want to plug them in here. And what is going on? Well, the only way to even get close to 0 is plugging in a 1. Then I still have that 1, so that won't work. Could I ever be less than 0? Well, anything I plug into these guys, if you look, I'm going to have this x minus 1 to this 2n minus 4. No matter what I plug in, this is always going to be an even, so I'm always going to get out a positive. So I can't ever be negative. So no matter what I plug in for x, f double prime of x is always greater than 0. That's, for all x that we have. So could I ever have a point of inflection? No. Okay? Not possible. That second derivative is always positive no matter what you plug in for x. Okay, so this is the end of, oh no, just kidding. We have the Lagrange error bound. Oh yeah. Sweet. Okay, so let's do some more. So alternating series versus the Lagrange error bound. And you can go watch this YouTube video. It's just kind of doing that. But let's talk about the difference. So the Lagrange error bound says we're going to take the exact minus the approximate, and we have this error. And the error is less than or equal to the next term. Okay, so like the next derivative, the next factorial, the next power. The only kind of thing why I put it in quotes is because that we have that z that we practiced. The alternating series says we have the exact minus the approximate, And that difference is the error, which is less than the next term. So they're really kind of saying the same thing, just one is a little bit easier for the next term from the alternating series, and one's maybe a little bit more challenging to kind of think through. Not always, but sometimes. So we're just kind of looking and seeing, like, it's that next term is what we're seeing. And you can read through what I wrote there as well. Okay, but let's do some practice just to really see if we can solidify this. So here's a Taylor series, yep, centered at 2, and it converges on this interval, so they're telling you. And it says the third degree Taylor polynomial for f about x equals 2 is used to approximate, so there's the x value, and then there's my center value. What is the alternating series error bound? Okay, well, I'm going to write out the first few terms here. I'm going to plug in my 0. I like to see what's going on. 2 to the first. Oops, the next one's a minus. It's alternating. And it keeps going. Okay, so it says the third degree. So the third degree Taylor polynomial would go until right here. So there's where my third degree ends. And it says it's used to approximate f of 9/4. So f of 9/4 minus the third degree here of 9/4, that's the approximation if I went and plugged it in, has to be less than or equal to the next term evaluated at 9/4. And that's what that error bound is saying. So, I mean, we could have plugged in 9/4 to find the approximation, but it just wants to know, what is the error bound? What is that? So, yay, we get to go try to simplify this a little bit. So this would be 13 over 16. 9/4 minus 4 over, nope, not 2. I need to get to 4. So 4 times 2 is 8. So that's 1/4. Well, that's not as bad. So 13 over 16 times 1/4 to the 4th. So that would be like 13 over 16 times 4 to the 4, and that was 4 squared, right? So that's 13 over 4 to the 6. What am I looking for? Let's see. Can I get it to match any of these? Oh, pause. Look back here. I just saw that. I swear I just saw that right here. So I didn't even have to go as far as I did. So I could have left it there, and then I see it. Okay, next one. So here is f of x, and t sub 3 is a third degree for f, so it kind of would have stopped it right there, the third degree. And so then they said that it's centered at C, and they got it to here, okay? So if I look at this, it says based on the Lagrange error bound must be equal to which of the following? Okay, so let's see how we did. So I know I want to look at f of x minus t sub 3 of x. That has to be less than or equal to the next term. And here this is not alternating. So if it's not an alternating series test, then I'm going to have to go to the next derivatives max times that x minus c to the 4th, right, the next power, over the next factorial. So if this is my f right here, then we need to go find all the way until the 4th derivative. So let's get the first derivative. Plus 3a to the third x squared plus 4a to the fourth x to the third. And let's get our next derivative. And the next derivative. And one more, the fourth derivative is this guy right here. So that is going to have to be kind of like that f fourth derivative at c. So I don't have a max. I just really have to put in, it's just a constant value the whole time. So, I mean, the constant value would be the max. It's like saying I have a constant graph, so that has to be the max output. Okay, so that error bound up there would be this 24a to the fourth. And then we'd want x minus c to the fourth over 4 factorial. And I'm not seeing any of those match up yet, but I know that those are exactly the same thing, so I can cancel. That would be a to the fourth x minus c to the fourth, and I do have that. So this was a really weird question. They're going to ask, I mean, I can't give you every single way that they could ask your knowledge. So it's like applying what you know and just kind of going with it intuitively. Okay. Okay, so really this next part with the whole AP practice, I want us to do in class together. There's just a lot of questions, a lot of really fun stuff to look at and to see. But I'm so proud of you guys. I hope you loved this section. It is, again, like my favorite. I love all of these series, and hopefully you're pushing yourself and saying that you're capable of so much more than maybe you even thought. I'm very, very proud of you, and I'll see you in class.